All right, good morning everybody. How's everybody doing this morning? All excited, are we? Great. All right, we're going to talk about our anaerobic digestion, but before we do, we have this competition again today. We had it yesterday, all the engineering firms here. Did anybody call you? Awesome. All right, how many engineering firms do we have in a room? Wave your hand if you're with an engineering firm, okay? All right, we'll let you all go. Is any groups in here? I know Hazen and Sawyer's here. What group do you represent? There's a group of girl Hazens over here. I hear you. They're probably going to win. I'm just going to let you know. Because they carried it yesterday and CDM stole it from them because CDM was playing the Price is Right game. So we're going to do a $25,000 difference, okay? All right, who else do we have in here? Don't be shy. Dixon, okay, who else?
Hybrid Engineering.
Hybrid.
Design South.
I recognize you guys too. Who else? Okay. All right, we're going to start from the back. All right, this plant was built in 1928. Modern road facility, first plant in Greenville here. All right, 6 MGD. Let's start in the back. Who is the last group all the way in the back? Yes, sir. How much did it cost? We don't have a lot of time, so you got to hurry up. No, I'm just kidding. Take your time. We're going to start on this side. No, I'm just kidding. We'll let you go first. Go ahead. There's no wrong price. Yes, sir. There's no wrong price. You can't. There's nothing to lose here, okay? But your pride. It's okay. $1 million. That's a pretty good guess. Okay, next group down. Yes, sir. Yes, sir. $2 million. Come on, guys. This is 1928. Where are you at? All right, no, I'm just kidding.
I'll say $1.5
million.
million.
$1.5 million. $500,000. We're getting in the ballpark. I'm just kidding. You're not even close. All right. I just say that so nobody gets the right answer. It's okay, guys. All right, who else was next? What engineering firm was next? Come on, guys, stop looking at your phone. Give me an answer. How much? $750,000. Okay, that's pretty good. That's $750,000. All right, who's next? No, you can't go. All right, are we down? Yes, sir. What were you at? Is anybody in here? We had one more engineering firm. The guy, yes, sir. The gentleman on the phone that's trying to figure out the answer. You can't look this up on. You can't look this up on Google, sir. You cannot look this up on Google. Yes. Now, hey, now, girls, give us the correct answer. $4.25 million. We're not going shopping, girls. 1.25. Guess what? America. Who was close is 625,000. Yes. Give the prize to them. All right. Awesome. That was the cost. Everybody kind of knows where we're at. We're in the upstate. We're in 5 counties. We have 8 different treatment facilities, 62 pump stations. I can skip all this because you know who we are. A little bit of our regional planning I will talk about. 2010, we had all these facilities. If we had a little list over here of the 90s, you would see it all the way down to the floor, because in the 80s, we were 38 facilities, but we regionalized these facilities. In 2012, we're down to 8. And I wish we could pump that one Marietta plant, but we cannot at this time. So we're going to talk about digestion and what we have, and we're going to talk about the 5 facilities where we have anaerobic digestion, okay? We're going to talk about thickening, how it's important to us and why we do it for the savings. And we're going to talk about our EMS program, our Certified Biosolids program for our recycled product that we do. All right, we're going to start at the Malden Road facility. 70 EMGD right now on the design, and you say, wow, you got 16 coming in and you're 70. What's the big gap there? Well, the nice sub-districts that we work with every day have this little problem called infiltration. And in the 90s, we built this huge interceptor, and the interceptor carried all that water to a wastewater treatment plant, which is great, right? No overflows in the system, because the state said no more overflows. DHEC said, there's a lot of problem down there in your park. Your lines are overflowing. So we built these huge lines. And guess what they collect? Stormwater, exactly. And guess what else they collect? Grit, yes, the magic of grit and what it does. And we'll see that in just a minute. But at this facility, We have UV treatment. It was the first biological nutrient plant in the state for phosphorus. And we're going to look at some of the things there. But first, we're going to talk about anaerobic digestion was put in the 40s at this plant. There was 4 digesters built. We're still using those tanks, and you can see those tanks. We have got our money out of those tanks. I just wanted you to know. That's when they really built tanks, by the way. And then we had 2 additional anaerobic digesters that were put in the 70s. And then all of a sudden, during the 80s, there was a huge phosphorus problem. There was big algae blooms in Lake Greenwood, and what happened then was, hey, guess where it comes from? It comes from the Reedy branch and Saluda branch running to Lake Greenwood. So Lake Greenwood had these algae blooms, and what was mandated that we went to biological phosphorus or chemical phosphorus removal at the Malden Road facility. There was only like a 30% chance, or so I'm told, that the biological system would work to get the numbers where we needed to be, and you would have to buy chemicals for your entire days. But guess what? The biological system worked. The A2O worked very well. But the problem was now we had a different digestion pattern. Our primary clarifier sludge went over to our digester, and our thickened waste activated sludge from our biological membranes went to a DAF unit. Why did it go to a DAF unit? It's biological phosphorus removal. It has to be aerated. So if you'll see the picture right here, and you could see that these were the DAF units that we floated the TWAs on, we pressed them out, and we mixed them with lime kiln dust. Okay? We made a A-class product. That A-class product was used at the landfill for daily cover, which was somewhat problematic at times, but we had an A-class that was with the lime eating through everything we owned and the employees. No, I'm just kidding with you. That was a joke. All right. So if we go on with this, so those 2 things are separated. So we took the primary clarifier sludge that went into the anaerobic digester that became biosolids, and we started the land application program. We were doing this at Durban. You'll see the facility in a minute already. So in '98, we started to land applying that. We had a B-class land application on this side. We had an A-class on the other side with the TWAs. So what happened during that time is we said, look, what we really need to do is we need to look at the differences between can we put TWAs in an anaerobic digester and have that release of a side stream of phosphorus back to this facility. And we did a series of testing for about 6 months, and it really worked well. So in 2000, we built 3 brand new anaerobic digesters that really, thank you Hazen and Sawyer, because you're going to see something awesome in a minute. They're going to shine on this one little building design that is awesome, and you'll see it, and it's actually right there in your corner, right here. The building contains the digesters, the pumps, the heat exchangers. Everything is in that building, even the GBTs. Really neat design, and there's the digesters being built. So in 2006, we even did more for the capital improvements. Blend cells were added, overflow tanks. We made the digester constant level digesters, even though they still had the floating lid. And we did 2 additional biosolids holding tanks. In 2008, we got tired of burning off that gas. There was funds available through shovel-ready projects, and guess what? With CHP was born. All right. So just a little look at Malden Road as the head works. We have the primary clarifier sludge, as I said before, that currently goes into the anaerobic digester. We have the waste-activated sludge thickened, of course, that goes into the digester. Then we thicken coming out, and we'll explain a little bit of that in a minute, to biosolids, and we're trying to hear 100% land application is what we try for all our facilities. And we're doing that again now after the PCB, and we'll talk about a little bit of that. So you can see from above, here's the Malden Road facility. This side's active. Here's your digester complex. A little bit up close, here's your digesters. Now we have the addition of the CHP. We'll see that in a second. Here's your building. It contains everything. And then we have a constant flow that comes off of these digesters if they're active, that comes to the overflow tank, is thickened, and then goes to the biosolids holding tanks. And here is our digester feed blend cells that we do different things with. And those are actually designed because we had some issues with foaming and loading, and we thought, is it the grease, is it this, or is it that? And we'll go on with that story in just a second. So here's the biosolid storage we added at 5 million gallons, covered biosolid storage, and here's the 1940 tanks that's still in existence that we use for backup. During the winter, if we're land applying, it gets wet, guess why? We don't want to run the belt press. Does anybody take a wild guess of running the belt press versus land application, what it costs? Hazen Star, you lost. What would you say? How much did it cost? No, in some scenarios, it's 50% more. That's a lot of money. That's a lot of money, taking it to the landfill, pressing it. That time, the trouble, the upkeep of the belt press is when you don't have that expense. We have all the land, and we'll go through with that too. So here's the old tanks. Here's the primaries that were built in the 70s, and the in-ground bunker secondaries that were from the 40s. So what did we include for mixing? Well, we have cannon mixers. You know, you can weigh the mixing options. It was a good presentation on the mixing. Might do a little bit better than we do on the grit, because at this facility with the grit loading, it's great that we have the huge vortexes that come in. They do really a good job. But how about if you pour everything in them in the ocean? It's really good that they run and they're designed to run at X amount, but how about when you get X, Y, Z, A, B, C, and D all at one time? That initial flush of that huge line, when you have these huge rains, are going to push some of that grit over into the primary clarifier, and guess where it's going to end up at? Either here or the holding tank. Depends on what's better mixed, right? So we have the floating lid. The gas storage is under these lids at this facility. Like I said, we have the cannons, the big bubble cannons that actually take up with the gas a big huge bubble, and they come up to the top. And here you can see a little bit of that at these levels. Here's our digester SCADA. This is what we're looking at, and it looks easy, doesn't it? It really is. It's not complex. You know why it looks easy and how it is easy? Nobody ever does anything to it. It just runs. Because right here is our feed cycles for the digesters. And you put them on how many minutes you want it fed. If T was primary clarifier sludge or scum, and guess what? I don't think these things have been changed in the past 10 years, because they run so well. And there's 2 running now, not 3. I took this picture when there was actually 3 running. Past history issues. The big thing was the level and the foaming. Okay? We can sit here and cry. We can sit here and roll on the floor about foam all we want. It's just one of those issues. But when we first got the new cannons, that was the thing. Because the operators were scared of the level that the digester went up. And they were in tune to run that digester at more of a low level. And guess what? The cannons, they were a little bit under or right at the cannons, and they weren't great mixing. They were just foam generators. And all of a sudden what they wanted to do was go cut off the mixing, because guess what? It was foaming everywhere. That was a nice snow picture, wasn't it? But what would happen is we would have that issue. The other thing is Nocardia. Nocardia in your biological treatment will devastate your digester. We had a lot of issues with that. In fact, before the PCB issues, we had grease haulers come in the groves, and they would put that into the headworks, and guess what? That grease would travel down to the primary clarifier, kind of go over the weirs of the primary clarifier, because the scum beach couldn't handle it. It goes out to the biological treatment, and guess what? We would develop scum during some times of the year, and it would be Nocardia. And that Nocardia would be fed to the digesters, and you would have issues. Those are the issues. So were the cannons, when the cannons in the level. That's why in 2007, we put the digesters at a fixed level with those floating covers. And there's the accumulation of grit in the holding tanks. And these are the digesters on the right, the holding tanks are on the left, and that's a lot of cleanup cost. So, and we also have the little problem here that we'll talk about is you can grind up anything you want to that goes into the digester, and you think it's going to be nice and clean on the other side. There's grinders in this digester. This is things that were reformed and wove back together. We have enough problems there at every facility looking at that. So the Pelham facility is our second largest facility at 22 MGD. It's around close to 10 now on the average. It's located on the innery. It's not biological phosphorus. Tertiary treatment, anaerobic digestion, and UV treatment. Here's a picture of our biosolids holding tank and our digester complex. 1998, there was aerobic digestion, and we started our land application process here as well with belt press backup. In 2005, the plant was upgraded to include new primary clarifiers, anaerobic digestion, and biosolids holding tanks. So we learned kind of from our foaming issues at Malden. So a lot of little things we put fixed lids in. So we had 3/4 egg design here. Biosolids overflow with that fixed box, same thing we put at Malden. We overflow to the biosolids holding tank. And there you see what we just talked about. One of those nice membrane. And I said yesterday, you didn't say it, but I'll say it today. We were scared. The first thing I said is somebody's going to take a gun and somebody's going to blow us all up. But Jared did not explain that you can't do that, okay? But that's what we thought. And Jared, by the way, if anybody says anything about where you work or asks you where you work, tell them you work at the jewelry store. That'd be awesome. Yeah. No, the flaming arrow would be safe too, wouldn't it, Jared? Yeah, it would. There's protective membranes over there. Okay, here's a little shot of the SCADA system and the plant control there, and a little other shots of your waste flare and the top of your digester fixed lids, the way they look. All right, past history. You have stoppages at times when you have screening issues. This facility has been one of those issues where we have fine screens up front. Guess what they were doing? Large rainfalls, they were jumping the gate, were not adjusted. Screening issues go back into the primary clarifier, go into the anaerobic digester, and there's lines. And then you have the magical black fairy dust that comes in and you didn't know where it come from. But everybody's heard our PCB issue with the hauler that come in with his nice little truck and backed up to some nice established restaurant and said, "Hey, sir, could we pump out your grease trap?" And they said, "Yeah, go ahead and pump it out." And he would come with a nice load of PCBs and he would blow it out into the sewer line and they would magically float down to our plant. But here's what happened. We put frac tanks at Malden Road. Everything goes to Malden Road. We put frac tanks at Malden Road, and we would test each frac tank before we released the grease right into the digester. So guess what? The grease was not going to the primary anymore. It was going directly into the digester. So Malden Road always had scum, right? Seasonal scum. Guess what? As soon as we did this at the Malden Road facility and took that grease load directly to the digesters have not foamed. The tops of the aeration basin has been just crispy white, like it should be. So eliminating grease from the biological system has done wonders there, but I need to get back on the PCB impact here. But we actually saw this day the parts come in and they were over 500,000 parts per million that we sampled on top of the basin. By the time they got to the biosolids, we had over 137, 160, 130 in the tank. The grease mat was around 130. The issues here were we could not go to an ordinary landfill. We had to go to Alabama. Alabama loves us for this. Yeah. Our estimated cost of what we tried to show the insurance company was $9 million at the 3 facilities that this happened to in the upstate. Okay. Lower Reedy, 3rd largest plant 11.5, 6 million. B&V, is anybody from B&V in here? Okay. Awesome biological treatment designed for phosphorus. Okay. We have several ways, UCT, VIP, modified UNC, you name it, we could probably do it at this facility because of the design and the piping and outlay and the 5 zones before the basin. Deep basin does a wonderful job. Their phosphorus, since startup to today, is under 0.2, no chemicals. Awesome job on that design. And going back to this, 2004, we started land applying those biosolids. 2006, we added this 60 days of storage. And does anybody see anything special about the digester system right here? Anything out of the ordinary? Anyone? The cover, yes, what does the cover look like? A prince's crown, right, girls? Yeah, I know you're going to say that. No, that is the one thing. I was going to say Burger King last. There's only one. There's only one. But being only one, we'll say this, the digester was a little bit over-designed on the cannon mixers, and we're about to clean those bad boys out, aren't we, Hazen? Sorry. Yes, we are. Because there's some issues there where we have screenings as well. The digester hadn't been cleaned out. It needs cleaning out. We need to consider build out of that plant and building another digester and looking at doing so. The digester, a little bit strange thing there is a TWAS tank added. At Malden Road, we would add that biological TWAS with the loaded phosphorus directly in, maybe to lock up some of those enzymes. Here, it was more of sitting in a tank and some of it releases more before it goes into the digester. They have a little bit more phosphorus in their side stream, but does a good job at the Lower Reedy facility. And we did the overflow tank as well. But here's the problem at Lower Reedy, this struvite. We need to harvest it right away. But anyway, our last director was not a big fan of the harvesting, but maybe our new director is, who knows. But here was the feed box that come down and it went underground. The overflow box comes down and it went to these 2 tanks that we're looking at. And what happened was this magical crystal that you could form, which we could grow this as diamonds, but we cannot, started doing this to a lot of the lines. And because we had this stagnant line that stayed full sometimes, it would attach to the cell walls. So what we had to do, we had to go back and say, do we do a chemical clean? Or do we do, take out the piping? What do we do? So the logical thing was coming out of the digester, added this gravity flow line, and so we're flowing all the time, and that's what we did for these 2 pipe locations here for the struvite. And of course, I talked about the screenings, a lot of that issues because the digesters have never been cleaned out. Gilder Creek, a lot of good things here I'm going to talk about. This is 11.3. This is on, anybody ever been on Woodruff Road in Greenville? You should visit there at Christmas every year. But anyway, it's out toward that way on the bottom side of Woodruff Road where all the build out and the growth is. Somebody tell me what this was called? Yes, sir. Yes. What kind of design is this called for this type of carousel? The folded hot dog. In 1998, I remember it like it was yesterday because I was there when they built. I saw them building this. They had the folded hot dog. It was one of the innovative plants that was 75% government funded. And we're going to show you another one of those in just a minute. But they built this out and they put in a great system here for the solids. Is nobody from CDM here, right? They can't do math because they pump 7 times. I'm just kidding, it's a joke. Jim told me I picked on too many people yesterday. And they did carry over on the $1. Hazen and Sawyer were so close just then they put $1 over on their bid for the plant, so I'm sorry. 2005, Gilder Creek was upgraded with new anaerobic digesters. Biosolids land application shortly after. Here's our storage tanks. Here's our digester complex. Really like these digesters. They're a little bit more narrow and a little bit more deeper, a lot in the ground. 6 30-inch cannons. They got an inside transfer pump instead of the constant overflow. Sealed partial shell designed with crom tanks. We have the gas storage unit here as well. Has done a great job. No problems whatsoever. Very low maintenance. The two winners on this is the scum concentrator and the sludge cleaner. So if you got $500,000 that you got to put in the job, it's well worth it. We can sit here and you can talk to owners all you want to. Hey, put $500,000 in something. I think it's well worth it. And I'll explain a little bit of that. The thing here with the digester, a little bit tall, narrow, a little bit deeper at 55 feet. Here's a little construction picture there. Here's a picture of the plant control systems on the digesters. Here's your membrane. Here's the sludge cleaners, and this is what they do. They take, through the primary sludge, they will take all that stuff out. It's nice. You need to take some of this home. It smells good. You can put it, if you put it in the kitchen, no flies will be in the living room, I guarantee you, okay? So, but the winner, I think, is the scum concentrator. How many folks out there see primary clarifiers in the waste of water, that you're spraying water in the primary clarifiers or secondary clarifiers to move that trough and to move that junk out? Well, you want to put all that water in your digester and steal the capacity, and just dilute your digester down, more heating that you'll have to do. Well, you know what? Concentrate it. This is really a winner because all the scum goes to this concentrator. The grease floats up top. It goes to a tank here in the basement, and you set it to slowly feed the digester at the pace. It's heated up already. You don't have to heat it. Small heating unit there. It was really one of the winners with the scum concentrator because the biosolids at this facility are very clean coming out. Not as clean as the membrane plant. We'll talk about that in just a second. Durbin Creek, near and dear to my heart. Durbin Creek was our first land application site in 1988, folks. Yes, 1988. It was a farm there. It's 5 million, it's 1.57 today. 1988, first permitted land application site. And who can tell me what the name of this? Jim, you'll have to do it. Nobody here can. What was the name of these?
Boat clarifier.
The inner channel are boat clarifiers. The salespeople say boat. I don't know why. Do you see the boat anywhere? I'm just kidding. But here is actually the clarifier. And we added turning vanes because of velocity issues. Plant did a really good job, but the plant was an energy monster because of the brush aerators and the velocity you would have to take here through the aeration system. Primary clarifiers, digester, and holding tank. This was all put in place. This actual picture is from the original plant. Here's the land site at that time, 5 fields. See the delightful hay that we have, Class B product, great hay. Had to sample that hay. You really have to check the nitrates in that hay so it's not poisonous to farm animals. B-class material. So we were doing this already. This was, for us, we saw the money and the savings and the manpower and the labor and the equipment and said, hey, this really looks great. Let's throw our eggs in one basket. Can we? But for the money at 50%, do you do that? It's a good fight there. So what we added in 2007 was we took the gravity thickener and we turned it into a TWUS holding tank. So we could waste during the weekend and not having to work about different man hours or so forth coming in, and that would be a constant feed. The only thing is, TWUS stored smells delicious if anybody's never smelled any. It's not as bad as pure grease, but it's pretty bad. And then you have, with this, we had the overflow, constant overflow was added, and the thickening building was added. And you can see, look at the inner channel clarifier. It used to take 2 of these to run before we hit the plant out. Look, 1/4, and we put anoxic zones. Plant does really good on biological phosphorus removal, and we didn't mean to because of the oversized clarifiers. So anaerobic digestion at Durbin Creek for the cannon mixers, and this was kind of not the rule of thumb, as these folks up here can tell you, that you really don't put anaerobic digestion in at a plant that's only a couple million gallons. because of different things that happens, because sometimes your TWAs outweigh your primary. And when that happens, guess what? We have too much turnover because of the cannons in here, and this facility still has the foam issues. So we're fighting this, and a lot of the flow is being taken off this plant. So we're looking at different options at the Durbin Creek plant. All right, why do we thicken? We thicken, just like I said before, because we want to concentrate on thickening going into digester. And the reason we do is because we want the available space that goes into the digester so the detention time will be lower, so we could take the food, respond there, and make gas, break down the solids. So if you look at the primary clarifiers, something that everyone has seen over the years with primary clarifiers, during the winter, the solids concentration can be as high as 6 or 7%. But during the summer, when the temperatures are high, you could go ahead and see, look, higher temperature means thinner solids. So this waves during the year, so we might have to compensate with TWAs of what we're putting in with our TWAs. We have mostly GBTs that thicken before and we thicken afterwards. Yes, we do have side stream loading that comes with thickening afterwards, but there's a lot of savings there. We also have a facility that has a rotary drum thickener, lots of clean application. Look at on the floor, it stays as clean as it could be. But nobody knows what the filtrate rate is because it's hidden, right? No, you put a solids meter in and you know what it is. So both of these units do very good for us. We have different types of GBTs, and there's our RDT. And why do we thicken on the backside? Because of the cost. At 2%, most of our digesters are coming off at 2%. We want to go into the holding tank at 6% because it breaks even further down when we store. When we store this material at 6% coming off the GBTs, guess what? We'll do good to be at 4%. Because we did this as a scorecard element of the utility management system, and this was on our scorecard element to go to 3 to 4% biosolids, and it was a savings of $250,000. And we pilot tested at 5%, was a little bit too heavy. And you can see our TWAS feed is around close to 6% that feeds into the digester. We kind of range between 5 and 6. And we developed during this time and this elements that we have to, every facility had kind of on our WIMS program, we had a tracking of what you were doing. What's your solids going in? What's your samples average through the day? What was your efficiency, your output, your polymer type, and your costs? So we had all this zeroed in of who was doing better. It's kind of like a competition between all the plants, right? And folks did their best to minimize the polymer, up the efficiency. But not only that is everybody learned a little bit more about what they were putting into their holding tanks for biosolids. Here's one of the 60-day storage was mandated as our upgrade, so we would have more room during the wintertime when it rained. We have a National Biosolids Partnership, our EMS program. In this, every time you do anything in the plant and you touch solids, guess what? There's a procedure for it. Every facility has a procedure for everything. And you say, wow, how do you do all that? Procedure is plan, do, check, act. And it's been amazing. It's been amazing because it's taught everybody a lot about what they do every day. But not only that, there's training and there's interviews from the director all the way down to the utility worker. And they know because they turn over the little name tag and they know exactly what the biosolids is because everybody's interviewed. We have different randomly people selected to be audited through our system to know what that system is. And we have an internal audit with a team and an external audit that comes in every year with improvements. We have over 7,800 acres permitted in these 4 different counties. Our largest farm is 10 acres, and our largest farm is 610, smallest is 10. We also, in our system, all our SCADA systems are interfaced to one program. So we made this for our biosolids manager so he could actually see what was going on at all the tank levels and where he knew where to go, because he was on the phone with somebody and somebody would say, yeah, my tank is filled up. His tank's not filled up. So guess what? He has to call no one. He just looks at this page. He knows exactly where to go. And you can see that the membrane thickening process we're going to talk about is pretty good this day at 3.5%. All right, so CHP, Malden Road, we got tired of all the wasted gas. So guess what? We moved into looking at something, putting those costs back to our grid, because Duke Power is so good and works with you. Raise your hand if you think Duke Power is a great entity that works with you every day. Raise your hand. Okay. No, we had options. We really chose to put it back because of different things. But and then we're going to talk about making some nice wine. Don't get excited, we're not going to make any today. But anyway, if we look at those treatment costs, we talked about biosolids, the top 4. Electricity is the second for our field. So we looked at methane, the hydraulic head of a lot of falls of the effluents. We looked at solar. Solar's back, by the way. Solar is somewhat back because Duke Energy is saying we'll do so and such for solar for you. So that's being looked at some of our facilities. So methane was the way to go. Everybody knows that it takes methane to heat your digester. Everybody's been doing this for many years, about 33% here at Malden Road. So we looked at cogeneration, fuel cells, heating bill. Everybody thought the vehicle thing would be the way to go. Was not, took a lot of money. So looking at this, we looked at the heat recovery of cogeneration. We looked at the effects of siloxanes. And girls, you know that's, I'm not picking on you girls, but siloxanes come from you, personal care products, we all know that. The storage capacity that we had in sizing up the engine, our experience, we did this in the 40s, we did this in the 80s. Hey, when we did Durbin Creek, we did this in the 80s, and Duke Energy charged us twice the cost it took us by putting a line back to them and transferring that power back. So we shut down the system. There was no working there after 3 years. So we had documented success. We called all these folks, asked them what they were doing, and everybody who had success was more with the spark ignited combustion engine. We had a landfill next door. Landfill said, hey, we remember working with you. You didn't do, yeah, but you know, we got this new gas unit. Come join us. Be a part of the party. Let's make energy. Let's reduce carbon footprint. They said, no, thank you. So we moved on. And we said, okay, we got this project. Here it is. Here's our hydrogen sulfide removal on our gas conditioning, goes through here. Siloxane removal with our carbon. And here's our engine generator. We also put in gas blend unit for if anytime we would like to do LP gas and team up with Piedmont Gas, but that hadn't folded out yet either. Maybe one day. Here's the engine at 800 kW. But if you look at the maintenance costs, a lot of folks say, yeah, let's do this. Look at the maintenance costs, it's pretty intensive, okay? But when you come down to the electrical cost, the difference is around $250,000, let's say, a year, and what you're saving. So there is a great savings. We're not putting all that methane and we're wasting it. We're putting it back to our own grid. The problem here is if you were in Europe, this would be killer. Because if you pay 26 cents or whatever for energy, it'd be different. We're paying 6.5. We're reducing that down. 6. We're reducing that to 4.5. One of the ways we're doing this, by making our gas, we started taking in sugar water, early 2000s, to make VFAs for our biological phosphorus system. We converted this old gravity thickener into doing that. We put sugar water in there, and guess what? It fermented and turned to wine. So what we said, well, you know what? We could do this there. Plant's been doing well, feeding a little bit less here, and started doing it as digester feedstock for the CHP and upping that gas. So if we look at here, we can see the products. You're not stealing them from us today because we have them hidden. But what we do is on the sugar water products, we will measure the brick. The brick is the sugar content, okay? And you can see that day was pretty darn good because it was so good some waste went out. Usually that doesn't happen, but I had to capture that for something else. So one of the better things we've done in a while is when we did our last design for our greenfield plant, we went with membranes. And not as well as membrane treatment, but membrane thickening. A lot of people may have gone out to see this. If you haven't, we welcome you to come out and see it. It's a prized plant. We have headworks, we have wet weather storage, we have EQ, fine drum screens, and here is what we have the magic, what we're going to talk about real briefly, is the TWAS membrane holding. Another shot of those things, and they're all in one building in one location. Makes it really nice. Here's your TWAS thickening membrane, one cell. Here's your 4 biological filtrations for your biological treatment. And this has been amazing. Extremely clean. Drum screens are ahead of this that make that and rescreening process, but this has been average since startup around 4%. Awesome. No chemicals, no labor involved. The plant is really a SCADA controlled system. Not a lot of labor there. Just high-techy guys, right?